Answer your attendance. Afla,
Present, Miss.
Ajmina,
Present, Miss.
Amaya, Atulya, Drishya,
Present, Miss.
Jyotish,
Present, Miss.
Karthik,
Present, Miss.
Kavya,
Present, Miss.
Nachiketas,
Present, Miss.
Neeraj,
Present, Miss.
Rangeet, Vaishnav, Anjali, Shruti.
Present, Miss.
Amaya is there. Atulya is there.
Present, Miss.
Okay. Right. I have given you a homework last class, right? You have to compare between TCP and UDP. Afla, just give me the answer. Just compare your TCP and UDP protocols. Have you written it?
Yes, Miss.
Yeah, then tell.
TCP is connection-oriented protocol.
Yeah,
UDP is connectionless protocol.
okay.
TC is slower and less efficient in performance than
What I
UDP
didn't hear.
and more efficient than
TCP is?
and then
Your voice is breaking. What you told as the second point?
TCP is slower and less efficient than UDP.
Then?
UDP is faster and more efficient than TCP.
Okay.
Retransmission of data packets is possible in the case of packet get lost in TCP,
Yeah. Then?
and
You tell about
retransmission of
UDP
packet.
also the same thing. Okay. If you have to compare, you have to just tell it opposite way. Yeah, one is a reliable protocol. The other one is unreliable protocol. One streaming is possible. The other one is datagram oriented, right? Now, TCP, you are having a sequence number provision is there, but there you don't have. Okay. All of you have written that comparison between TCP and UDP. Yes or no?
Yes.
Yes. Rangeet is there. Rangeet, Vaishnav,
Yes, Miss.
Vaishnav, Anjali,
Understand.
Anjali,
Understand.
Amaya. So absent is Anjali, Rangeet, and Amaya today, right? Now, last class we were just discussing about congestion, right? Now, what is congestion? When can congestion? What are the common causes of congestion? Who will be answering? Yeah, Shruti can answer. What is congestion? Or when congestion occurs? Shruti? Yeah, your voice is breaking. Okay, some other person can tell. Shruti. I cannot hear you. Jyotish can answer. Jyotish is there. Jyotish.
മിസ് വോയിസ് ബ്രേക്ക് ആവുന്നുണ്ട്, ഒന്നുകൂടി പറയുക.
When congestion occurs. or what is congestion in a network? Is it clear now? Jyotish?
മിസ്സേ
Yeah, tell. When congestion occurs in a network.
congestion reduces the quality.
No, I'm just asking when it happens. What is the condition? As far as network is concerned, when congestion occurs. Ariyamo? Okay, the other person, Ajmina. You were there in the last class? Ajmina, yeah, you were there, right? Yeah, make it fast. Ajmina is there?
Yes, miss.
Yeah, tell me when congestion occurs. ഒന്നും വായിക്കുന്നില്ല ഡെയിലി ചുമ്മാ പറഞ്ഞു വിടുക നിങ്ങൾക്ക് അല്ലേ അന്നെന്നുള്ളത് പോർഷൻസ് അന്നന്ന് കവർ ചെയ്തില്ലെങ്കിൽ വളരെ ബുദ്ധിമുട്ടായിരിക്കും Now Kavya can answer.
Congestion occurs if the load on the network is greater than the capacity of the network.
Okay, so congestion can occur if the load on the network, load in the sense number of packets that are sent to the network, if it is greater than the capacity of the network. Capacity means the number of packets that the network can handle. Then if it is greater, you can tell congestion has occurred. Now, it is mainly due to the queues in the routers and switches, right? And based on that, I have just told you about some traffic descriptors, right? What are the parameters that you have to consider? What are the, I have shown you a graph versus traffic versus, time versus data rate. And there you have specified some parameters. Now, what are the terms that are used in traffic? Who will be telling? Atulya was there in the last class. Atulya, she's not there. Atulya. Rangeet.
Miss.
Yeah, tell me. What were the terms used in traffic? We have drawn a graph between data rate and time versus data rate. So adila yana oru moonu terms paranju parameters paranjittundairunnu. What are they? Ariyamo? Tell yes or no, because I can't waste time. Ariyamo Rangeetna?
Constant bit rate.
You have denoted it as the peak data rate, the average data rate, and the maximum burst size. These 3 points endannulladu like what it means I have just explained. And generally you will be having data flow can take any of the 3 traffic profiles. One is with a fixed rate, the other one is with a variable bit rate, and the other one is with a bursty rate. ഇത്രയാണ് നമ്മൾ കഴിഞ്ഞ ക്ലാസ്സിൽ പഠിച്ചത്. Now today we will be just seeing about the congestion control mechanisms. Congestion, I have told you what are the different causes of congestion, right? Now today we will be just seeing how you can control congestion. Now all of you listen here. Now, congestion control mainly, it is nothing but you are making use of some techniques or mechanism. Either you can prevent the congestion before it happens, or once it happened, you have to remove it. That are the only two possibilities, either preventing or removing the congestion. So if it is based on that, the first category, you can call it as the open loop congestion control, which is nothing but it is called it as prevention, open loop congestion control, and closed loop congestion control. That is called it as, one second. Okay, one is called it as the open loop congestion control. The meaning is you are preventing it, and the other one is called it as the closed loop congestion control. What you're doing is you are just removing it. Right? Now what are the various classifications of this open loop congestion control and closed loop congestion control? Now, generally, open loop, it can be further divided based on your source and destination. Based on your source and destination, you can just divide it. The meaning is either one can control it, either they will decide who will be controlling the congestion, right? So if it is done by the source will try to control the congestion by introducing the traffic in a controlled manner. If source is having that responsibility, it is trying to control the traffic. But if the control is implemented at the destination, now what happens? It will make some suitable measures. The meaning is it will inform the sender such that the traffic is reduced. Understanding? The open loop, it is divided it into two categories based on, one is based on the source and another one is based on the destination. Now, who does the control? It can either be done by the source or it can be implemented at the destination. Now, if source is trying to control the congestion means, it will be introducing traffic in such a manner, right? Now, if it is implemented at the destination will be making use of some measures. The meaning is it is informing the source regarding the congestion, and so such that the traffic is reduced there. Okay, now the other type is called it as the closed loop congestion control method. You know what is the meaning of closed loop in control system and all. You have studied what is a closed loop. So closed loop means there is a type of feedback here, right? You are having a feedback. Now, here you can have two mechanisms generally. One is called it as the explicit feedback. The other one is called it as the implicit feedback, right? So you have two types of feedback here. One is explicit feedback. The other one is implicit feedback. Now, explicit feedback, explicitly you are doing it. Here, what is the meaning here is you will be having a number of nodes, and in that, some of the nodes, they will find out the congestion and they will decide who can control it. So that is the meaning of explicit. Now, what is the meaning of implicit? Implicit is based on the fact that whenever you are having a packet to be transmitted in a network, now what happens usually? The source will wait for an acknowledgement, right? So once it transmits the packet, it will wait for an acknowledgement. Now, if it monitors the delay in receiving the acknowledgement, now what the source will do? The source will decide that, okay, the network is congested or not. Okay, it is based upon the reception of the acknowledgement from the receiver side. So implicit feedback in the sense, whenever you are transmitting a packet to the destination, you are expecting an acknowledgement from the receiver side. Now, if the acknowledgement is not reaching for some time, or if there is a delay in getting the acknowledgement back, the source makes a decision there. It will find out whether the network is congested or not. right? Now, if the delay is less, it can assume that it is not much congested. And if the delay is more, it means that the network is congested, right? So these are the general form of this open loop and the closed loop mechanism. I have told you, open loop, it is based on either source or destination. Either one of it will be controlling the congestion, right? Now, here closed loop means you are having a feedback, two type of feedback, explicit and implicit feedback. Explicit, you will have many nodes in that. Out of that, some of the nodes, they will decide, okay, they will find out what is the, I mean, whether the congestion is prevented. I mean, and also they will check, they will make some control measures on that. Okay. Now, implicit means the source itself, it is trying to prevent the congestion if there is a delay in receiving the acknowledgement. Right? Now we will just go on with the category of this open loop congestion control methods. Now I have told you open loop. Open loop means you are trying to prevent congestion, right? Open loop means the objective of open loop congestion control is you have to prevent the congestion. Now, in order to prevent congestion, you are making use of various policies. Out of that, the first policy is called it as the retransmission policy. Second one is the window policy. Third is the acknowledgement policy. Fourth is the discarding policy. And fifth is the admission policy. So some policies are applied to prevent congestion. Now, what is this retransmission policy? Retransmission, it is also called it as timeout interval. You know what is the meaning of timeout, right? So retransmission, it is policy. It is also known as the timeout interval. Now, if you have a good retransmission policy, you can prevent congestion. Now, what it discusses is, it is discussing about the timeout interval. If the timeout interval is very small, now what happens now? Many retransmission takes place before receiving the acknowledgement. I have told you, retransmission happens when you are not receiving the acknowledgement within a specified time. Now, if that timeout interval, if you are specifying the timeout interval as a very less value, then what happens? Many retransmission takes place before getting the acknowledgement, right? Now, if the retransmission time is longer, the meaning is timeout interval is larger or longer. Now, what it means? There is a possibility that acknowledgement is received before the timeout takes place, right? And you don't be having the retransmission. The meaning is timeout interval helps in preventing congestion. Understanding what is retransmission policy? Retransmission, also called it as timeout interval. If the timeout interval is very small, many retransmissions takes place before receiving the acknowledgement. But if it is larger, then it won't be, retransmission is not there, right? Acknowledgement will be received within that timeout value. Okay, so the timeout interval, it prevents congestion. What is our aim actually? You want to prevent congestion. So what you will do, you will making out the timeout interval a bit longer. Understanding? Yes or no?
Yes, miss.
Yes, okay. So that is about the first policy to prevent congestion. Okay. Now, the second one is called it as the window policy. Now, you have studied about windows, right? You have studied in your flow control methods. Window policy is also known as the flow control. It is also called it as the flow control. Now, when I have taught you flow control, I have told you about two types of flow control methods. One is stop and wait. The other one is the sliding window protocol. Now, in sliding window protocol, you will be specifying the window size. Understand? Now, what were the two sliding window protocols? One was go back in, the other one was selective repeat. Okay, so whenever you use a sliding window protocol, now the number of packets that the network will depend upon the window size. You will be having a window, you will be specifying the total number of packets in that, right? Now, if the window size is very small, assume let it be 3 or 7, right? 3, let it be 3. What happens in that case? The traffic on the network will be very small. If you assume your window size is 3, the meaning is the traffic on the network is small, right? Now, if you are selecting a large window size, now what happens? The number of packets in the network will be high before getting the acknowledgement. So the meaning is by adopting certain policies for flow control, you can prevent congestion, right? You have to select your window size according to that. I have told the two possibilities, what happens if the window size is very small and what happens if the window size is very large. If it is small, then traffic on the network will be small. If it is large, you will be having number of packets to send before getting the acknowledgement. So you have to follow some policies such that the flow control, with the help of flow control methods, the congestion can be prevented. Right? So that is the second policy, open loop congestion control method, or the second policy. Now, the third policy. Third one is called it as the acknowledgement policy. Acknowledgement policy. You know, if you are considering a particular destination node, it can, if you, this is the destination and if this is the source, now the destination can send an explicit acknowledgement packet which reaches the source station, right? Explicit means the one which is clearly expressed. You don't have any intermediates there. You can directly send an explicit signal towards the source. Okay, now another possibility is that whenever you are having a full duplex communication. Now, what is the meaning of full duplex communication? You're having your host, sender and receiver, both can transmit on the same time. The meaning is you are having traffic on these in both the direction. Now, what happens now? Here, the destination node can send the acknowledgement by a form called piggybacking. Piggybacking. Now, what is this piggybacking? Piggybacking means usually in a two-way communication process. Two-way communication means in a full duplex communication, whenever a frame is received. See, you have a source, you have a destination. Now, once you receive the frame, right? Now, the receiver, it immediately, it does not send the acknowledgement. It will wait for some time until it reaches the second data frame. So, cumulatively, it will be sending the acknowledgement to the sender. So, technique of temporarily delaying the acknowledgement so that it can combine, both the data frames can be combined and sent to the sender. That process is called it as piggybacking. Understanding what is piggybacking? You will be having a source host and a destination host. Whenever you are sending a frame, the destination, it does not immediately send the acknowledgement. Right? It will wait for some time until it receives the second data or the third data. So cumulatively, they will be sending the acknowledgement towards the sender side. So that delaying process and combining the data frames and sending, that process is called it as piggybacking. Okay, now if I am doing it like that, the number of traffic in the network is reduced and thereby it prevents congestion, right? So if by making use of suitable acknowledgement policy, that means the process called piggybacking, if you are introducing, the congestion can be prevented in a way. right? So if the receiver does not acknowledge every packet it receives, now what is happening at the sender side? It will wait for an acknowledgement, right? The sender will be waiting for the acknowledgement. So it may slow down the sender. Sender is not transmitting the data continuously. So it may slow down the sender and helps in preventing congestion. Understanding acknowledgement policy. Acknowledgement policy is nothing but you are just delaying the delay in sending the acknowledgement towards the source, so that if the acknowledgement is not received, the sender may slow down its process, right? And that thereby the congestion can be prevented. Understood what is acknowledgement policy? Yes or no?
Yes, miss.
Yes. Okay. Now, the fourth one is called it as the discarding policy. Discarding, or you can call it as packet discard. Now, if you have a good discarding policy by the routers, that may prevent congestion and it does not harm the integrity of transmission. So you just assume if you have a good discarding policy, in one way you can prevent the congestion. Now, the last one is the admission policy. Admission policy means now you have switches and routers in a flow. Now, what the switches and routers will do, they will check for the resource requirements. They will check for the resources before a flow, before admitting it to the network. What it will do, the routers, they will check for the resource requirement of a flow. Now, if it is there, they will allow it. So admission policies are in one way, it will be preventing congestion, right? So these are the different open loop congestion control methods that you are using to prevent congestion. Congestion is happening mainly due to traffic, that is the load on the network. If it is greater than the capacity, congestion can happen. Now you want to control it. Either you have to prevent it or you have to remove it. Now open loop is nothing but you are trying to prevent the congestion. Now basically it is based on two things. One is either based on the source or it is based on the destination. So they will decide who will be controlling it, right? Now you have got, so in order to do that, you will have various policies. First one is the retransmission policy. Retransmission policy is also known as timeout interval. So timeout interval, if it is very less, retransmission will be very, number of retransmissions will be increased. So you have to keep the timeout value to a safer limit such that retransmission is not happening before receiving your acknowledgement. The second one was window policy. If what happens if the window size is small and what happens if the window size is more. If it is small, you have only a fewer packets that has to be handled by the network. If it is more number of packets are there. Now, acknowledgement policy, by process called piggybacking, you are trying to prevent this congestion, right? Piggybacking means delaying in sending the acknowledgement. A good discarding policy also prevent congestion, and a good admission policy. Admission policy means they will check for the resource requirements and then they will be admitting. They will be finally allowing the flow to enter into a network. So if you are looking all this case, you can just prevent this congestion. Understood what are the open loop congestion control method? Yes or no? Yes, okay. Now, yes, we will move on to the next type of congestion control, that is called it as the closed loop congestion control. Now, closed loop means you are removing the congestion. I mean, you will try to alleviate or remove congestion after it had happened. It had already happened. Now, what you have to do is you have to just remove it. Okay, now basically this involves 3 steps. This closed loop congestion control, basically it involves 3 steps. One is you have to monitor the system. You have to monitor the system for detection of congestion. The first step is for detection of congestion. The first step is you have to monitor the system for detection of congestion. The meaning is when and where the congestion has happened. You have to just monitor it. Now, the second one is pass the information to the proper place. Pass the information to proper place. Once congestion has happened, and if you had identified it or detected it, you have to pass the information to proper place for taking action to control it. For taking action. Right? So pass the information to proper place for taking action to control congestion. Now the third one is you have to adjust the system parameters. Adjust the system parameters. Right? So to get out of the congestion. So these are the 3 steps that you are just doing in this closed loop congestion control method. First one is you have to monitor when and where congestion has happened. Now you have to inform to the proper place for taking some action. Now based on that, you have to adjust your system parameters such that you will be getting out of congestion. Right? Now, in order to do all these steps, you have got different approaches. Now, the first approach is called it as the back pressure. Now, the second one is called it as the choke packet. The third one is implicit signaling and explicit signaling. So you have 4 approaches in closed loop congestion control. One is back pressure, choke packet, implicit signaling, and explicit signaling. Now, what is this back pressure method of alleviating congestion? Now, here you can see just a diagram. Now, in this mechanism, you have a node here which is congested. So a congested node, it stops receiving the data from the immediate upstream node or the nodes, right? So once it stops receiving the data, now what happens to this node? This may cause the congestion can happen in this node again. And what they will do, they will inform, or they won't get, or they won't take data. They will stop receiving data from the upstream node. So it will be going back. I mean, it is going in the reverse order. So finally, what happens is they are trying to reject data from their upstream nodes. So back pressure is a node to node congestion control that starts with a node and propagates in the opposite direction towards the source side. Ultimately, the source has to slow down the process, right? So whenever a node is congested, it will stop receiving data from the upstream node. So once it stops receiving data, this node will become congested, right? Now they will try to stop receiving from the upstream node. So like that, you are applying, I mean, the back pressure means that is a congestion control method that is propagating up to the source node such that the source slow down the flow of, flow of data. It will stops, or it will control the flow. Now, usually this type of methods you can just use in virtual circuit networks. This is only applied to virtual circuit networks, right? So in that virtual circuit network, you knows all the upstream nodes. You have a virtual connection between your source and the destination, and you know which are the nodes that are to be connected, right? It is not happening in packet switch network because you are having an independent path and you don't have a connection from your source side to the destination side. So this back pressure can be applied only to virtual circuit networks where each node knows the upstream node from which a flow of data is coming. Okay, so this is one method to remove congestion. Once a node is getting congested, they will be applying a back pressure towards the upstream nodes, and finally it reaches the source such that it shorts, it lessens the flow of data. Right? Understood what is back pressure? Yes or no? 5 more minutes is there, right? Okay, let's continue with. Understood what is back pressure?
Yes, yes.
Yes, okay. Now, the second one is called it as the choke packet. Now, what is this choke packet? Now, choke packet means this type of method. It can be used either in the packet switch network or in the virtual circuit network. Sorry. So this can happen either, applied in either in virtual circuit or in datagram type of networks. Now, what happens here it is, each node, they will monitor the utilization of the output line. Now, you will have a threshold value. Threshold value you will have. Now, once the utilization is increasing beyond that threshold value, congestion happens. So if the utilization goes beyond some threshold, now what the output line, they will enter a warning state, right? So the node, it enters a warning state. Now, if it is, now what happens, the meaning is, it will be sending a control packet directly towards the source. And that control packet is called it as the choke packet. And that is sent from a congestion node towards the source station. Now, once it receives the choke packet, the source station, it reduces traffic by certain percentage. Right? So you have a threshold, or if the utilization is going beyond a particular limit, usually some 80%, if it is like that, now congestion can happen. So if it happens like that, now a warning state it has reached, and it will be sending a choke packet or a warning packet, and or a control packet is sent directly towards the sender, such that the sender reduces the traffic by certain percentage. Okay, so this is the second type, that is called it as the choke packet. I think the time is up. Just we will continue it in the 5th hour. Right? Okay, so what I will just give a summary. What I have discussed today is about the two type of congestion control methods. One is open loop congestion control method, and the other one is closed loop. Open loop, you are preventing congestion. Closed loop, you are removing. It has happened and you want to remove it. Open loop, you have got various policies. First one is retransmission, acknowledgement, timeout, then admission policy, discarding policy. You have got various policies. Based on that, you are preventing congestion. Now, closed loop, two types you have seen. One is the choke packet, and the other one is called it as the back pressure method. Okay, understood? Right, just we will continue it in the 5th hour, the remaining things. And before that, I just want a few persons to call me by 11. Shruti should call me, just a second, by 11:55 today. Shruti is there? Yeah, make me a call at 11:55. And Vaishna is there? You have to make me a call exactly at 1:30. കുറച്ച് പേരോട് ഞാൻ വിളിക്കാൻ പറഞ്ഞിരുന്നു. ഐ തിങ്ക് ദൃശ്യ, ഐ ഹാവ് ടോൾഡ് യു ടു കോൾ ബട്ട് യു ഹാവ് നോട്ട് റെസ്പോണ്ടഡ്. ഒരു ടീച്ചർ ഒരു കാര്യം പറഞ്ഞിട്ടുണ്ടെങ്കിൽ അത് നിങ്ങളുടെ റെസ്പോൺസിബിലിറ്റി ആണ്. എപ്പോ?
ഞാൻ രാത്രിക്ക് വിളിച്ചിരുന്നു.
രാത്രി 9 മണിക്ക് വിളിച്ചു കഴിഞ്ഞാൽ ഞാൻ ഫോൺ എടുക്കണമെന്നില്ല. ഐ ഹാവ് ഗിവൺ യു എ ടൈം ഫോർ ദാറ്റ്. ആ ടൈമിനുള്ളിൽ ഇയാളോടും ചോദിച്ചിട്ടാണോ ഞാൻ അത് സമ്മതിച്ചത്? പെർമിഷൻ ചോദിച്ചിട്ടാണോ ഞാൻ 1:30 പറഞ്ഞത്? ദാറ്റ് ഈസ് യുവർ റെസ്പോൺസിബിലിറ്റി ടു കോൾ മീ. ഓക്കെ? Okay, just we will meet in the next class.